Hello and welcome to today's live seminar, Pressure Sewer Design and Application on Long Island, New York. I'm Rachel Seiler, today's host and marketing events producer for E1. We'll give our attendees just a few more moments to log on, but before we get started, I do have some housekeeping notes. All attendee lines have been muted. We'll be recording today's seminar and be available on E1's YouTube. Successful completion of today's seminar, you'll receive a follow-up email with information on how to access this presentation, as well as information on obtaining your CE credit. And finally, we'd love to hear from you. We've allotted about 15 minutes of Q&A with our presenters during today's session, so please make use of that time. If we don't get to all your questions, we'll be sure to answer them in a follow-up email. So now, without further delay, I'd like to introduce one of today's presenters, Chris Nedwick. You're in for a real treat here. Chris is the National Sales Development Manager for E1 and definitely knows his stuff. Chris has over 15 years of experience in both wastewater sales and field service and has guided many municipalities through successful pressure sewer projects. Chris, take it away.
Thank you very much, Rachel. And thank you to all the attendees who have taken the time to join us today. We're delighted that you have. We've got a lot of really good content that's specific to some examples in Long Island, New York, which is an exciting development for Environment One and for the community, and a lot of good content related to pressure sewer in general. And without further ado, I would like to jump into the agenda. So we'll talk a little bit about the company background, sewer systems in general, pressure sewers, design factors related to pressure sewers, the E1 system, and commercial applications. And then finally, at the end, we'll have some time for questions and answers, as Rachel mentioned. So a little bit about the history of the company. Environment One started as a General Electric research and development spinoff back in the late 1960s, really. The company was formed in 1969. We've been in the same location since then, developed the technology as a pioneer at that time and continue to do so. We developed the progressing cavity pump specific to residential wastewater applications, really starting with the design challenges and working backwards to the design that's still consistent to this day. We are the industry leader in pressure sewer systems and very proud to say so. We are in Niskayuna, New York, in Schenectady County in upstate. We have about 140,000 square feet. We're ever growing, available to us at our manufacturing facility, 140 plus employees. And in conjunction with showcasing E1 as an industry leader in this market and beyond, we're also proud to be partners with Site-Specific Design. Site-Specific covers about 45,000 square miles. So they have a very sizable territory with 4 offices and 10 full-time service technicians to support these systems as we install them. So the design criteria that was specific and original to low pressure sewer was actually pioneered by the American Society of Civil Engineers. And this really created the pressure sewer market as we know it today. Our design has been consistent with that criteria from day one. We continue to enhance and perfect and improve that design on a continuous basis from a continuous improvement standpoint. We have a global distribution network of sales and service entities, a singular focus on this technology with 900,000 manufactured units installed globally and really about 2.5 million end users that utilize our products on a daily basis. So our mission really is to provide complete and accurate design recommendations for pressure sewers to suppliers, engineers, and customers. Our focus is on the end user and the quality and optimization of the design. So we always just want to keep that focus on making sure that the customer experience is positive. As a trusted advisor, we support our customers from the planning and design phases of a system through construction and the life of system. We'll talk a little bit more about here today. Things like contractor training, end user training, service training. We really want to stay focused all the time on ensuring that things are done right and done properly. So our approach is unique. We have a purpose-built system. Everything that we offer as part of this system is interchangeable and reverse compatible. A consistent and predictable flow is really at the heart of our pumping system and the designs that we create in conjunction with engineers of record out there in the community as well. We want everything that has to do, or every attribute or aspect of these systems, to be consistent and predictable. There's zero preventative maintenance required with E1 systems as a UL approved appliance. Very, very important to our overall philosophy. Simplicity of repair and or replacement also very important, and it's something that helps keep cost of ownership as low as possible. Safety is number one with Environment One, not only as a company, but with the systems that we provide. We want to make sure that safe operation is top priority and that maintenance is something that's always kept efficient and as simple as possible and as low cost as possible. Continuous improvement is something that I mentioned earlier. You know, we really have a strong focus on making this technology more reliable, more predictable, and keeping that cost of ownership to the end user as low as possible. So this slide shows sort of the evolution of the technology from 1969 all the way on the left. That's our company founder, Mr. Paul R. Farrell, with the first prototype. And as you move to the right, you can see that the design has stayed similar throughout the years. And really, from day one, as we are today, we have been a single horsepower progressing cavity pump system with pressure switches for controls and air-filled motor. And that is something that we still offer to this day. And it's, again, designed specifically for the application. So we have more systems than the rest of the industry combined, starting with Port St. Lucie down in Florida with 16,000 homes and businesses currently connected. Saratoga County, a similar number at 15,000. I won't read through every bullet here, but Indianapolis, Indiana with 10,000+ homes. In Long Island, we're already up to almost 5,000 homes at this moment. So the idea here is to show and demonstrate that this is not a new technology. It is a proven technology with entire communities that rely on E1 for their wastewater services. And experience matters as well. In places like Albany County, with the original prototype system that we implemented 56 years ago, these systems are still running strong after all this time. So this is, again, a proven technology with a demonstrated track record. And I'd like to hand it over to my colleague, Rachel Seiler, at this time for a poll question.
Hey, Chris, thanks. Everyone should see this poll question. If you want to take a moment to weigh in on what wastewater collection system technology do you mainly specify and or design? Just one choice. We'd appreciate learning more about what's going on in your market, in your company. Okay, we're gonna 2 more seconds and we're gonna end the poll. I think we have just about everyone participating, which is great. Thank you. And I'll now share the results, Chris and Sean. So we have about 75% of the group gravity and 26% pressure sewer.
Yeah, so you know, looks pretty interesting and kind of what we would expect for the marketplace. You know, I think most people on the call might know me. My name is Sean Cameron with Site Specific Design. We are the manufacturer's rep for Environment One in the territory, and I'm going to talk to you guys a little bit more about the experience and stuff we've done on the Long Island market up till now. So specific to the Long Island market, you know, we have about 3,500 connections in the Charles River area that took place over the last 2 to 3 years. A bunch that have taken place in Patchogue. There's a huge project that's underway right now in Forge River that isn't on the list yet because they're not in operation. But as you can see, we've done a lot of different installations and applications on the island over the years. You know, we've connected to date more than 4,500 homes and businesses across the island. We've been doing this on Long Island for over 27 years. The first system went in a long time ago. We service over 20 different towns and villages throughout the island. We help bring several of these key projects to fruition with different technologies and tools that we have at our disposal. And again, in the future project pipeline over the next 5+ years, there's a lot going on there. New projects popping up every day. We remain fully committed to that cause. Our goal is we want to work with the design engineers, the contractors, the municipalities, regulators, and everyone. There's a huge challenge when it comes to sewering areas, and we're involved in working with you guys on that. Patchogue specifically, we like to touch on. They were the first place in Long Island to really adapt the pressure sewer technology. So currently to date, we have about 700 homes and businesses that are connected, and more going on this year. But their first system went in back in 1999, 2000, that era. Was a couple dozen connections down on West Ave and Main Street. We've been involved with them since the beginning. H2M architects and engineers were involved in that original design. And, Chris Weiss has been a key player in that from that engineering group since the beginning. These systems, serve several Main Street businesses. Realistically, if you go to almost any restaurant in Patchogue, there's a chance that it's connected by pressure sewer to the gravity system, as well as a lot of the southern neighborhoods down near the South Shore. One of the things that made this possible for Patchogue and all the other areas is, of course, a functional wastewater treatment plant. Patchogue was kind of ahead of the curve on this. They built their own plant many years ago. It's currently up and rated for 8,000 or 800,000 gallons per day. But to date, they're only really operating in the 400,000 to 500,000 gallon per day range. So they have pretty good amount of capacity already. But as we're looking at this, we intend to continue expanding on this. So in the meantime, in the background, they are also working on looking at some plant upgrades and increasing that capacity to about 1.2 million GPD. So, a lot going on there. So funding, for this has come from many different areas. We had the Wastewater Infrastructure Fund for Suffolk County, CWSRF funds, and New York State environmental funds. Lots of different areas, but obviously a huge need in Patchogue as well as some of these other areas. So, finding the funding has been key to getting that done. So we're going to touch just on kind of sewer systems as a whole. I imagine for a lot of people this could be review, but we'll go through the basics. So as we saw on the poll there, gravity sewer is something that a lot of people have worked with and designed. Pretty traditional design. You have a pipe coming out of the house into a collection system located in the easement or roadway. You're going to have that pipe connects into larger diameter pipes in the road, and eventually that will go to some sort of a manhole or pump station or directly to the treatment plant. This is a very widely known functional sewer technology. Secondarily, probably the second most well-known technology there is would be septic tanks and cesspools. So again, we have wastewater flow comes out of your structure, could be a house or business, into a holding tank. Now in Suffolk County, for example, as most of us know, prior to 1973, there wasn't even a requirement for a septic tank. So a lot of this flow was just going straight into cesspools. In 1973, they came up with the regulation that you had to put a septic tank in front of that flow to collect the solids. And then the effluent that comes out still goes into the cesspools in a lot of areas. Approximately 375,000 homes in Suffolk County that are connected to a cesspool, and approximately 275,000 of those prior to that 73 when they were built did not have septic tanks. That number may have gone down recently with the new regulations. If you pull a permit, you either have to go to the septic tank or some of these other technologies we're going to talk about going forward. So with septic tank and cesspool situations, you tend to have issues. With any technology, there's going to be pros and cons. With septic tanks and cesspools, as those units break down and fail, you can leach these, pathogens and noxious material into the ground. In Long Island, we're on a very high groundwater table and above one of the largest natural water aquifers in the world. Obviously, there's some more issues that could come to play there. So, just some downsides of what you can see. So as a result, Suffolk County did a case study back in 2012 area where they looked at kind of the state of the wastewater situation on Long Island. And what they found was that more than 400,000 septic tanks, that were there. 70% of those were installed before that 1972 that required the septic tank that says septic tanks, but I think it's cesspools. Um, a lot of these were having issues and failing, and they were, 69% of the nitrogen flowing into the Great South Bay was a direct result of these failing septic and cesspool systems. Obviously, that had negative effects on the ecosystem. Obviously, anyone who lives on the island or has been there, the fishing and shellfish situation has changed off the shore drastically over the years. And a lot of that is a direct result of these high levels of nitrogen just going straight into that, ecology and ecosystem. So nitrogen levels in the groundwater, they exceeded the federal drinking water standards of 10% in residential wells. So they realized that obviously there was a problem, and they had to look into, what options do we have? So out of that study, obviously it took time to, do all the research and research different technologies and what good options were. They came up with two primary ways that they were going to address this. The first of which is the IA systems, innovative alternative septic systems, if you will. So these are essentially little packaged treatment plants that get installed in the ground in someone's backyard or side of the house. These can also be used for commercial applications. So the way these systems work is flow comes out of the house, goes through a septic tank to hold back the solids as well. Then the effluent goes into a treatment chamber or multiple treatment chambers. And that effluent is treated by introducing an oxygen source to let the bacteria live and thrive. Your carbon source is your wastewater, so that's kind of a food aspect for the bacteria. And then you need a surface for that bacteria to grow on. So some technologies use just the walls of the tank. Some have little balls or bags or plastic discs. There's several different technologies that are approved in Long Island. Each of them do it a little bit differently, but at the end of the day, it's kind of the same process. We're growing bacteria. We nitrify and denitrify to get that total nitrogen levels below 19 milligrams per liter. And then we're discharging a much cleaner effluent into the ground, into that same either cesspool or a shallower depth type dispersal system at that point. The second type of technology that they looked at, and what brings us to our conversation today, would be pressure sewer systems. So as Chris had touched on some of the history, we get more into what is a pressure sewer system. So the basic view is that you have a tank, wastewater from the household flows through the pipes into this tank. As the water level in the tank rises, there are some sort of a level sensing device on the pump that's going to activate that pump. The pump will turn on, grind up all the wastewater into a fine slurry, and pump it out through a small diameter pipe to the road. Smaller diameter pipes in the road can get bigger as more connections are made, and then it eventually will pump to a treatment plant or something of that sort. The grinder pumps can be installed outside in a yard. They can be installed in the basement, just somewhere that they can collect the flow from the residential or commercial connection. And obviously, we want to keep the discharge lines below frost grade to keep them from freezing. I always like to note that a grinder pump is different from an effluent pump, to where an effluent pump is normally used in a lower level of a building for just one level of sewage to pump up to an already existing gravity output. These pumps are typically designed for entire flow of a building, and we are grinding everything up and pumping it into just about anywhere, but the ultimate design is a pressure sewer system. So as a result, the grinder pumps are here to stay. It would be safe to say that the IA technologies are doing very good in areas as well. The grinder pumps in areas where there is a centralized collection system and wastewater treatment plant, Bergen Point, also Patchogue and some of the other areas. The grinder pumps have been kind of the go-to there where you can centralize it and get even lower levels of total nitrogen that get into the ground afterwards. To date, Suffolk County has installed over 3,500 plus grinder pumps in the last 2 to 3 years, and we are actively in the process of doing another 2,000. That should be done here by the end of 2025. The majority of these were in the Carls River area, and Forge River is the project that's going on right now, so that's Shirley Mastic area. We've done several hundred, obviously, as we discussed in the Patchogue area. We've also done projects in Northport and East Quogue that we continue to grow on. As well as tons of onesie, twosie applications throughout the entire island. The force mains were installed in the streets, and then the grinder pumps were contracted separately to be installed on each individual property for all these connections. So at this point, I'm going to pass back to Chris to talk about some of the technology on a deeper level.
Thank you, Sean. So at this point in the presentation, we'll talk a little bit about some of the different types of technologies that have been mentioned already. We'll start with gravity sewers, and these are myths and misconceptions. One of the largest misconceptions that we've all encountered over the years is that once gravity sewers are installed, they're free. This is not the case. Gravity sewers are actually very costly to maintain. Anyone that's seen a Vector truck or a closed circuit television system or witnessed smoking testing taking place knows that it's a pretty involved process and tends to be very expensive. So that is a myth and misconception that there's no regular maintenance required. I&I is a very serious problem throughout the industry, and gravity systems are susceptible to that. And we test gravity systems in this industry to ensure that to locate I&I hotspots and eliminate them so that there's not different complications and troubles downstream at the wastewater treatment plant throughout the system, and that there's no cost associated with transporting and treating in I&I. It's one of the most costly line items typically with any organization responsible for maintaining a gravity system. Chasing I&I is a big deal, and there are lots of firms throughout the country who are devoted specifically to this. Also with cesspools, not having to pump them out regularly. Anyone that's been around the various communities in Long Island know that emptying cesspools on an annual or even just every couple of years basis can be very costly. And there are industries associated with this that are dedicated to it. And this can be quite costly, anywhere between $600 and $1,000 to pump out a cesspool. And, frequently cesspools have problems when there's periods of higher usage, things like birthday parties, holidays, special get-togethers. So these are all things that we're aware of that we would like to highlight, and that they're not a problem for the environment. Cesspools are a very rudimentary technology that are prone to leaching out and leaking into the surrounding environment with very little to no treatment in certain cases directly into the aquifer. For example, Sean mentioned a study that identified up to 69% of some of the pathogens and pollutants that made their way into the Great South Bay eventually were traced to leaky cesspools and septic tanks. One of the misconceptions that we see with pressure sewers is that constant maintenance is required and that it's expensive to operate. We're unique in the industry in that as the leader of the technology, we're dedicated to keeping O&M, what we call O&M, operation and maintenance costs, as low as possible. They're not expensive to operate. We know through third-party data that one full-time service technician can service up to 1,400 homes in some cases. And that even when you factor in energy costs, even with inflation in recent years, $30 to $35 a year is typical, right? So it's a very cost-effective way to introduce sanitary collection. What does it look like? This is an E1 station, and we take great pride in everything that goes into the design of this system. And we try to make them as innocuous as possible. And we try to fashion the tank in such a way that it can blend into the neighborhood, the yard, the natural environment. It is an earth tone meant to kind of blend in. We want it to be somewhat hidden if that's in fact what the homeowner wants. In some cases, these might be located closer to the point of demarcation between private and public lands. If the public entity is in fact taking care of and maintaining the system, it might not be behind a bush like this, but as design engineers, it's important to know that that flexibility is afforded to you. And once it's installed, it does blend in. And there are a variety of different options available to in keeping with this theme. That's what we call a fake rock. It's a rock that covers the cover. So underneath that would be the cover that you see on top. And that helps it blend into the environment a little bit more. And then the system on the right is an IDU, or an indoor unit. That's a 90-gallon tank, comes with a 5-year warranty, and that can be located inside of the dwelling, the residence. It can be buried in the slab, so to speak. So all you'd see is the very tip of the cover, or it can sit on the slab like you see there, and it's piped up basically to the main ventilation in the plumbing system, in the house, and the main stack. And this is a panel on the left, an E1 panel. That's our design. We own the mold. We're in the process of updating this now, making it even better, but that's a NEMA 4X enclosure. I think pretty much everything that we install into the Suffolk County market has that gen receptacle on the side of it, which is a nice feature as well. And that's also NEMA 4X rated. And here's just another shot of the cover itself on the right. It's the enclosure is what we call it. That's a technical term for it. And that is a alarm panel. It's not a control panel. So the controls in our system are installed in the pump itself, and the alarm features predominantly are what's located in the enclosure. So a great question we hear is, where do we use pressure sewer systems? And the answer to that is really anywhere where the flows are appropriate. But what we see mostly is where there's undulating terrain, not such a prevalent condition in Long Island. Now you do have some of that. You get a lot more of that upstate in other areas, but where the soil's rocky, that's going to be the case more so on the North Shore than the South Shore. Where you've got a high groundwater table, that could be the case anywhere in Long Island. So because of the fact, or due to the fact that it's a small diameter technology that's far less invasive than gravity, you've got less excavation, so you have less issues in managing groundwater and really controlling those flows and documenting those flows and having a place to put them. Flat terrain, that's a geological condition that is prevalent in the Long Island market. One of the things I just want to pause and touch on is that we drastically reduce the amount of lift stations that are required, or in many cases outright eliminate them. So flat terrain demands lift stations when used in conjunction with gravity. So when you're eliminating lift stations, in many cases, you can be eliminating, with the potential to eliminate, millions of dollars from the budget of your project. So that's a very appealing thing that engineers look at when considering pressure sewer systems. And a really important point, this last bullet, is in conjunction with existing sewage collection systems to expand the service area. So we're seeing a lot more designs that might have some gravity that are also utilizing a hybrid approach, where pressure sewer might be designed for the peripheral aspects or portions of that project, to have just a different approach and make it more consistent, maybe with a budgetary demand, or deal maybe with some more demanding regions where some of these geologic conditions are prevalent. So really the takeaway here is E1 pressure sewer, because it's progressing cavity, and we can follow up and have a more in-depth treatment of the hydraulics associated with this. But we play well, so to speak, with gravity, with existing manholes, with headworks at wastewater treatment plants, really with any type of, almost any type of existing collection that might be there. So how does this all work? Solids are macerated with an E1 pressure sewer system in the station itself, basically to a fine slurry. It's then discharged out of the station into a small diameter network of pipes. And again, we're different, we're unique. We consider the system itself to be that small diameter network of pipes, which we're going to deal more with in some forthcoming slides. But we want to optimize that system. We want to look at things like retention. How long is that wastewater going to be in those pipes for? We want to get it from the house to the station, out to the treatment plant as efficiently and quickly as possible, so that you don't have odors and you don't have septic conditions and things like that. So that pipe network is something that we pay very close attention to. What are the diameters of the pipes in that system in certain places? What's the material that's used? What's the installation method? These are all things we're going to work with you on in your designs. The wastewater is pumped, so there's no slope required like there would be with a gravity system. There's no pitch that's required. All of a sudden, you can, as a design engineer, can pump uphill, downhill, can go around things. Maybe there's a coveted or cherished, tree or something that's important to the community that you don't want to disrupt in any way. Well, because of the flexible nature of this technology, you can work with that and go around it and preserve what we call the vernacular of the landscape, or the main characteristics of the landscape. Anytime you can introduce sanitary collection in a way that's not invasive, that's ideal. The network is fully sealed, so it's resistant to stormwater infiltration. We mentioned I&I before. That's a huge budgetary cost on the part of many municipalities and even private customers in some cases. We're a pressurized system, so there's no infiltration possible if that system is installed properly. And again, we work with the engineer, with the certifying entities, and ultimately with the contractors to make sure that approved construction methods, we're walking through that journey with you from the beginning till the end to make sure that these systems get installed properly. Sean Cameron's on this call. There's not a system that will go into the Long Island market without him being intimately involved in training that contractor to make sure best practices are being followed. We take that very seriously, and that trickles right up to the factory. We support site-specific in that endeavor as well. And simple installation. In the wastewater world, simplicity equals reliability and low cost of ownership. So we really we latch on to that simplicity aspect of our approach and our solution. A lot of times we're seeing horizontal, directional drilling used. That's been very prevalent in some of the larger projects in Suffolk County. When the Carls River project was installed, they didn't even have to shut down Sunrise Highway. There was limited disruption. So high traffic conditions, different societal type impacts are all mitigated. When you're reducing the excavation that's required for a technology, you're reducing things like off-road diesel pollution, noise pollution, that sound that construction vehicles make when they back up, that beeping. No one wants to hear that at 7 a.m. So if you're mitigating or reducing the amount of excavation that's required, you're also subsequently addressing all of those other downsides, if you will. And again, no critical slope is required. So here's what the system looks like. It's kind of a subterranean cutaway view of the station that also shows the home on the right, and really the public lands, if you will, call it the street, where the curb box is called out on the left. But pump systems with positive pressure are common and more intuitive than other systems. Therefore, technicians are more successful in diagnosing and correcting faults. So what that means is that if there's an issue at, call it 16 Main Street, the technician will be able to quickly understand, again, through the training that we provide, what's going on there. And if it's the middle of the night, they can simply remove a core and replace it with another one and come back the next day when it's more cost effective and less impactful. The technicians can get on and off private property as quickly as possible. That mitigates and reduces risk. And that's something that everybody pays very close attention to. Grinder pump stations provide a level of emergency storage in the event of a power outage as well, or an equipment fault. So with our stations, if there's a terrible, or with our solution, if there's a hurricane that comes through and there's some type of prolonged power outage, well, you've got emergency storage inside that station that can be depended upon in that situation. You also have the generator receptacle, if it's a really super extended type situation, that can be utilized to evacuate or discharge the wastewater from that pump system itself. Again, with 2.5 million end users out there and all the different power disruptions that take place, most of them taking place in the wintertime, like now, this is not really something that we hear about. It just doesn't take place. We don't have situations where the power's out for so long that people can't utilize their critical services. And in times when there are critical power outages and they could be extended, Water usage is often reduced by more than 90% in that home itself because you're no longer using a washing machine or a dishwasher and things like that as well. Grinder pumps and low pressure sewer systems actively process solids and debris with a grinder. So everything that goes out into that system is a clean slurry. There's no disruptions, no blockages out there in the system itself. So something important to keep in mind when we're thinking about the operation of these systems. No critical infrastructure is also something that we'd like to point out. There are other technologies out there that rely on centralized infrastructure, things like big lift stations to work, maybe backup generators to work. If you have a vacuum system, if the integrity of the vacuum inside, that characteristic inside of that pipe network is compromised in any way, you could have an entire section go out. That's not the case with a pressure sewer system. So if Sean and I were neighbors and there was an issue with my system, it wouldn't impact his system. He would still have that critical service. And again, system abusers, this is something that's really become a high priority for operators and municipal managers. People abuse sewer systems, any type that you can possibly imagine. We've all heard the stories of things that make their way out into the gravity system, causing problems, right? Things that don't belong down the drain with the Water Environment Federation terms, prohibited items. With a pressure sewer system, all you have to do, the technician would have to do is pop that cover, pull that core. That process would take less than 5 minutes, look inside that tank and quickly be able to understand what the issue is, if in fact there were prohibitive items making their way out of the house. And pressure sewer systems have, again, virtually no stormwater infiltration. So we just wanted to reinforce that point here as well. A frequent question we get from design engineers are, hey, what can we discharge to? And there's a lot of flexibility here. Gravity manholes, what we call a drop connection, as you see on the right. A gravity main, as long as we're able to overcome that force main pressure, we can, through a saddle tap or another method, connect directly to a gravity main. A wastewater treatment plant, a lift station wet well, and in some of the forthcoming slides here, we'll talk about the hydraulic characteristics of the E1 pump. 185 feet of total dynamic head is a very capable pump, and it's going to be able to overcome system pressures in the vast majority of cases, and we find that to be the case. That's why many engineers utilize this technology where they have maybe an existing force main that might be close by. By the way, we had this interview with Mayor Pontieri, who talked from the village of Patchogue, great man who talked about kind of the history of their system. And he made a very interesting comment. It's those long distances where the costs are really incurred with any type of infrastructure, but certainly with wastewater. If that force main is a mile away and you're connecting to it with a 4-inch or less, for example, E1 force, pressurized pipe, well, the cost associated with making that connection is reduced significantly. So the lower cost of ownership, the lower cost of installation extends beyond just the system proper. It's getting to that other type of infrastructure, collection infrastructure that might be present as well, again, with minimal disruption. We can go to septic tanks. We don't see too much that Suffolk County and a lot of the regulatory agencies down there are really moving away from what we would consider a traditional septic tank, but we do have examples where communal type septic systems have been used and utilized with great success over long periods of time. Treatment lagoons is one of the things that I'm thinking about in particular here. So those options do exist as well. And some of those have been proposed out east and over the years. We can follow up with more information on that as well, if that's interesting to you. And on-site systems, these IA systems that are being utilized, Sean could tell you more about where E1 systems have been used in conjunction with those as well. And larger intermediate grinder pump stations, a lot of times these are E1 systems, and we're seeing a lot of these being installed down there right now, but it could be a larger, flight station, a HOMA station, or some other type of large, what we call big iron lift station manufacturer. More times than not, we can integrate seamlessly with those as well. Vacuum systems, we don't see any of those down there, but there are certainly other cases where we have interfaced with that type of technology as well. Very important point to emphasize is really our design approach. I mentioned previously in the presentation that interchangeable equipment is really factors heavily into keeping cost of ownership down. We want the end user to be able to keep one set of parts on the shelf and have one type of training and one type of knowledge. We make one pump for this application. The variation with an E1 system comes in the tank itself and in the panels, and maybe in some cases, certainly we see it a lot in Long Island with the communication equipment that it comes with as well. Engineers, one thing that I've learned over the years, love predictability, right? You don't want to install something that's not going to behave the way that you intend it to. E1 systems, highly, highly, highly predictable technology, and we can demonstrate that through our application design process and pretty much tell you what each zone in that system and each section of that system, how it's going to behave. Everything from retention time, total retention time, to velocities per second, to what size that pipe is going to be, to where each station is going to be located, where that force main should be located, things like air release valves, service connections. We're going to make all those recommendations to the engineer of record, and we discuss those aspects with them before they stamp it and actually put it into use. Simplicity of repair and replacement. Again, as a UL certified appliance, we like this technology to be invisible to the homeowner. I've received phone calls over the years from folks who said, "Hey, I built this house in 1990. I had no idea that I had this thing." And on the one hand, it's unfortunate when there's a service issue, but 30 plus years of invisibility, we can hang our hat on it and say, job well done. That's what we want. We have a proprietary software system called Design Assistant. We have the most capable team of design engineers at the plant who can walk the engineer of record through this process, designing these systems through this software, which you're able to download from our website, www.e1.com. And really, it's a program that designs these pressure sewer systems and ensures that they are optimized and designed in such a way that we approve of, and that's going to produce years of reliability. This image on the right is our performance curve. You'll see how there's a negative condition below zero, and it goes up to 80 PSI above that. You'll note that this is not consistent, or it doesn't resemble what would be a typical centrifugal pump curve, for example. This is almost vertical. So what this means is that, and again, going back to some of those earlier slides in the presentation, the folks that designed this technology from day one understood something that's very critical to understand about pressure sewer systems. You're going to have varying system pressures. So being the case, you need to have a pump that's going to work pretty much no matter where you put it, as long as that system behaves within the total design criteria on the system curve. So this pump is going to be predictable. It's going to deliver anywhere between, call it 8 and 14 gallons per minute, no matter where you put it. Could be up at 80 PSI, could be down below zero. It's going to behave in a way that's predictable. So on the topic of application engineering designs, there are a couple keys to our design. We can really get you started with something as simple as a Google Earth image and maybe just 4 to 6 other areas, bits of information that are critical to understand to get at least a back of the napkin type understanding of, A, whether the system will work, B, what the potential budgetary costs would be, and C, what it would look like. Couple of those keys, as we call them, a layout of the lots to be served. So if you're working with an existing municipality on a cesspool or septic to sewer initiative, you're going to have a plot or a drawing, if you will, an as-built that shows where the property lines are, where the homes are. We'd like to have that so that we know where the connections are going to be originating from, what the potential flows per connection / lot would be. With a residential application, we use, depending on the local regulation, about 250 gallons per day. If it's commercial, it can exceed that. On those commercial connections, which Sean will talk more about, we really go through great pains to have a comprehensive understanding of A, what's going on there, B, what is the expected daily usage, C, what is the solution recommendation for that location, what pipe type. Typically, we use Schedule 40 PVC, DR26. SDR11, we see a lot of SDR9, SDR21, I think we see a lot of down there as well. That's rated up to 160 PSI. The burst pressure on those, depending on the material used, can be as greater than 300 PSI. So a very resilient, robust pipe network. These pressure sewer systems are tough once they're installed. But we do like to understand how those systems are going to behave in a peak flow condition, really at any point in the life of that system. Topographical information doesn't factor in so much in Long Island, but we've done some work in places like Northport where, you know, there is some static lift. So we're going to want to understand what that static lift is so that we get a really clear understanding of how the hydraulics are going to behave with that system. And the discharge location or end pressure sewer, this end of the pressure sewer system, is it going 300 yards or is it going 3 miles? Obviously, this is going to influence the system design. It's going to influence the head pressures and things like that as well. Climate, you know, with a winter like we're having now, we can appreciate things like minimum frost depth even more. We pay very close attention to those, and we want to make sure that we're working with the engineer of record to ensure that those are achieved and adhered to. Code requirements, you know, we work hand in hand with Suffolk County and other municipal entities to ensure that we're meeting their regulations and what they expect of you and of us to make sure that these systems comply with their regulations as well. Sean has an intimate understanding of that, me less so than him, but certainly quite a bit of it. We can walk you through that and help eliminate risk when it comes to your design as well. Really any other relevant information regarding geography, flows, site conditions, requirements. A lot of those things tend to get flushed out, no pun intended, during the discussions that take place as a result of these AE studies, as we call them. And pipe sizing is really critical to this area of discussion. So just to give a quick overview, and I'd like to just pause and say, you know, between site-specific and design, you know, working hand in hand over the years, we've really interfaced with a lot of engineers in the Suffolk and Nassau County markets to help educate them on how we design systems, so that you have confidence in the design that you're producing on behalf of your client. But basically what we utilize is called the probability method. And what the probability method spells out is what are the total number of pumps, that will be operating simultaneously at any given time in a system. And we do that through zones. And we compartmentalize the system into zones. And as the system, it's basically like a water system in reverse. And as the system grows downflow in that direction, we add zones, and we add those zones each time SIMOP increases by a rate of 1. And retention times, you mentioned that before, and what the total dynamic head will be in that system at any given point in any given time. This chart on the right, this is a hypothetical, and it starts up on the top with 1 pump and eventually evolves down into more than 1,000, 1,004. This really encapsulates the beauty of a low pressure sewer system design. It's why we can maintain that small diameter pipe, because we're not designing for the flow rate that would come in one chug, if you will, from 1,004 homes. We're designing for the SIMOPs that we know will take place in that system, which is on the right. So we're actually designing that pipe for 35 homes flowing at one time as opposed to all 1,004. So that's really where the magic lives. We'll work with you also on placing air release valves. We call for those as well. And also with the piping size and the piping type, we'll walk with you through that area as well. Design Assistant, if you want, if you're interested in this, this is the program that I mentioned previously. It's a proprietary program. It's basically the probability method is utilized through Design Assistant, and with some very basic inputs, system can be designed. And Sean and I would love to follow up with you, anyone on this call that's interested in downloading Design Assistant, to walk you through how this works. But if you're looking at a potential system, Design Assistant is a great place to start that conversation. And we provide training on this, and also do this, provide this service free of charge to the engineer as well. The unilateral is a critical piece of equipment that we recommend. We actually require it as part of our spec. It's a stainless steel 316 series stainless steel system. It's a 3-in-1 design. There's a flapper style check valve, a clean out, and an isolation valve. and very corrosive resistant, being that 316 stainless material, fully tested from the factory. So when you receive these, you know they're going to work in the field. They're rated up to 235 PSI. This would take the place of off-the-shelf plastic components that have to be glued together by a human being in the field, a technician. And it's really a great way to reduce risk and know that that system is going to work very well and is going to produce years of reliable performance. We do go from 1.25 inch up to 2 inch on those. The 2 inches you see mainly with commercial applications. The system that we use in the Long Island, provide to the Long Island market, is the D series. It has wet well, dry well tank architecture. It's fully serviceable. Ease of serviceability is something that really factors heavily into the design of this system. It has a dry well on top, what we call safe dry pit, and the wet well on the bottom. So the wet well, exactly as the name infers, is where the wastewater is stored, and on the top is the service area. The candy cane curved piece of metal that you see on the right is actually the discharge. The technician would show up, isolate power from that system, isolate flow from that system by lifting the flag valve that basically encapsulates the top of that candy cane, effectively isolating system pressure, extracting the core from the tank, and then providing service or conducting a service call. This process can take place in less than 15 minutes, so it really does help keep cost of ownership down. Everything with these tanks is dictated by the invert depth, so we can go to 160 inches. In your market there, you probably wouldn't see anything less than a 93 or a 74-inch station. Field adjustability really is something that's critical to field installation. A lot of times, maybe the invert doesn't line up the way that we thought it would, or you thought it would in the field. So a simple phone call to Sean or Zechariah or somebody from Site Specific Design, they can show up with an extender, if you will, that can help adjust that basin height. Our tanks are double wall constructed, again, specifically for the application. So you know that, and that tank itself, before it leaves our factory, is vacuum tested. And you'll see an LCO and chalk written on the side of every E1 station that's in the field that makes its way out to the customer. That means that that tank is watertight and the welds are, and everything on that thing is going to operate, behave, and perform according with our expectations, and more importantly, with the customers. The core itself is a unique area for us. It's a modular design, so everything that pump needs is located inside of the tank itself. And the electrical quick disconnect, or the EQD, is what you see on the left. That takes the place of a junction box. And it's a 6P rated designs, again, specifically for the application. Makes serviceability a lot easier, a lot safer, a lot quicker. And as I mentioned before, our alarm panel is truly an alarm panel, not a control panel. The controls with an E1 pump are located inside of the pump itself. They're specific to the pump itself. And with that, I'd like to turn it over to my colleague, Sean Cameron, please.
Sorry, Chris, I skipped a slide there. So I want to touch on some of the commercial applications for the E1 products. So similar to everything that Chris has talked about here, all of the same physics and everything come into play with commercial applications. Obviously, the biggest difference is flow. So we have a variety of different systems that we can look at for different flow applications. I don't know why the screen keeps changing on me without me changing it, but that's okay. So we've done a lot of different commercial applications in the past, everything from Alcatraz, Dover Speedway, SpaceX, a bunch of residential applications with townhomes and things of that. We can handle flows of 10,500 gallons per day in a single quadplex. Even our duplex systems with the D series, like Chris was talking about, we can do up to 6,000 gallons per day with one of those. And we've done even different applications where we have multiple quadplexes if needed to handle even higher flows. So as discussed, that gives us a different variety of basins. So the unit on the left, as Chris discussed, that's more for residential. Then we get into some larger duplex configurations, all the way up to some open wet well designs you see all the way on the right with the W series. When we get into very high and custom applications, we go with some fiberglass or precast applications. So the one here in the picture on the left, that would be actually a tank over, let's say, 10 to 12 feet. We would recommend putting the pumps on guide rails for serviceability and accessibility. Um, and then, the ones on the right back there, that would just be your more shallow unit. Control panel offerings, as Chris discussed, alarm panels, control panels. We have a whole gamut of these depending on your application. So the best thing to do if you have any application, residential, commercial, reach out to us. We can work with you on the design of what is the right tank, what is the right panel to achieve your goals and your flows for your end user. Go to the next one here. There we go. Century Advisor is another key tool. This residentially, we're using this for all of the county projects so that they can get alerted when any of the residential units go into alarm, since the county actually has to take care of the O&M on those units. Commercially, for me, I feel it's even more important. If I owned a business and that business is my livelihood, I have a pump station that may have an issue. This is going to be a way that I'm going to be able to get notified and have historical data on how my pump system is working. And then from our side for serviceability, it gives us even more information that we can utilize to, make sure that when we arrive on site, we kind of have an idea of what's going on with the system and how to better approach the service of that system. So, quick summary on what we've gone through here. Low pressure sewer is a definite market that is, in play in Long Island. E1 is the, birthplace of that technology. We've been doing it a long time, so obviously, reach out to us if you have any projects that you think might be applicable for this technology or any technology we can work with you on. The systems are easy to design, they're easy to install and operate. They operate, it's a appropriate technology for high performance value applications, low upfront cost in comparison to some other technologies. There's a worldwide team of guys like us that are here to create relationships with the customer, and we're trying to create that relationship for life, where we work with you from design all the way through serviceability. We want to be that trusted advisor for you. As I said, call me. There's plenty of times I have engineers and contractors call me and I'm like, we can't help you with that, but I know someone who can. We're not scared to say it's not our place. So that gives us a little bit time here at the end for some Q&A. I'll let Rach take over from here.
We do have a couple questions that have come in. I know we're running a little bit tight on time. Here's the first question, Jen. What is the maximum bury length for the inlet pipe into the pump station? And what is the max riser that can be added to the pump station?
So I'll touch on that one. So the invert depth of the pipe, as Chris said, standard in like Long Island market, you're going to have something from a 74-inch tank to maybe a 93. So that would give us maybe anywhere from 4 to 5.5 feet in the ground on our traditional invert depth. We can go up to 200 inches, even with the E1 like D series stations, which gives us an invert depth of about 13 feet under grade. Honestly, I showed that drawing with the guide rails. Serviceability wise, anyone who's ever gone out on a service call and pulled some pumps and any pump, when we start getting to some of those deeper depths, we might look at different options, whether it's D series or maybe a guide rail setup, or maybe just like our guys have different hoists and stuff on the truck. So there's a kind of an unlimited depth that you can go if you go with that fiberglass. I have a tank I'm working on right now that's 25 feet deep. It really, whatever your application is, we can typically find a way to make it work for you.
And this question from Mark, he would like you all to discuss buoyancy.
It's a good point. I'm going to let Chris take this with the new D series DH071 tank, and just keep in mind that that might be different than some of your larger stations.
So counter buoyancy is a critical aspect of the E1 station design. We, about 2 years ago, came out with what's called the universal wet well, which is a wet well design that is intended to eliminate the need for a ballast itself. So the tanks will not float in any condition that you can think of there in the Long Island market. We have testing that backs that up. We have thousands of these things in the ground now, but counter buoyancy is absolutely part of our design criteria. It's something that we take a look at very carefully. We have a team of engineers. If you have any concerns, I will be happy to walk you through that to demonstrate how it works and why it works. But basically, the geometry of the tank captures enough soil load to function as a counterbalance, a buoyancy, if you will. So that once upon a time, what we did was put ballast on these tanks. We've evolved past that point where that's no longer necessary. With some of the commercial stations, you might have to have it. Certainly with some of the fiberglass stations that Sean mentioned, but with the D series, W series pumps that we have, it is designed into the design of the tank itself. It's part of the design of the tank itself, and would be happy to follow up and discuss that further.
Final question, kind of speed round from Steve. For shallow depth pipe installations, can you install without check valves and slope back to pump station to avoid freezing?
Sean?
Yeah, traditionally I'm going to go with no. So aside from the secondary check valve, that unilateral stainless steel assembly that Chris Nedwick was talking about, there's an integral check valve built into the pump itself that won't allow flow back to the tank. Typically, the reason for that is if you're pumping out a certain amount of gallons and then you're leaking it back into the tank, you're reducing your actual storage capacity in the tank and pump volume for each cycle of pump. So it's not something we would typically recommend in most applications. But that being said, we've done some pretty unique things over times to make things work. But the traditional setup, it would probably not be able to work that way.
So we are about a minute and change over here, so it looks like we're out of time. On behalf of all of us at E1, and especially our presenters, Chris and Sean, we thank you for joining today's seminar and look forward to seeing you soon. Be well.